All right, so welcome to Chapter 2, where we're going to learn about research methods. So in Chapter 1, we learned that psychology is a scientific study of human behavior and mental processes. So in this chapter, we're going to learn, well, just how is it studied? What are those research methods? We're also going to be addressing parts of Appendix A, just introducing you a bit to statistics, not much, but we need to have an understanding of how some of these research results are summarized and presented. So in this chapter, again, focus on the learning objectives. I'll call your attention to them as we talk about them in the lecture. So we're going to talk about what the scientific method is and how it applies to psychology. We're going to learn about some terms and concepts like sampling. And then we're going to talk about different levels of research. So descriptive research, correlational research. We're going to talk about experimental research and some terms that are important to understand in experiments like reliability and validity. Then we're going to talk about some different types of statistics for summarizing the data we get in those research methods. And then finally, we're going to review what are the ethical guidelines for conducting research. So our first objective is to describe how psychologists use the scientific method. The scientific method in psychology is the same as in other sciences. And one thing we have to emphasize with the scientific method is that it is a cyclical process, that it starts with somebody having a question. That question, as we learned in Chapter 1, might come from somebody's dissatisfaction with an existing perspective or an existing explanation for something. So once someone has a question, then they try to gather as much information that's already in existence about that topic. So that means reading all that has already been published about that topic. If it's something entirely new, then that might mean having to go in and just make some observations on your own. And then based on the existing data, the next step is to come up with a hypothesis. What is the best guess you have about why something is happening? And then you design a study and collect data that will help you answer your question. You will analyze your results, and if your results support your hypothesis, then you have an obligation to write it up and summarize your results so that the next time when someone else has a question about this topic, your data is there for them to read and help them develop their own hypotheses. If your hypothesis was not supported by your data, then you have to cycle back through the process. So did I guess wrong? Did I come up with the wrong way to study and collect the data about it? So the scientific method is continuously building on the past research. So we're going to take this step by step. So the first step is to develop your question. That question is based on your own observations and the kinds of things that you have noted about the world around you. It might be based on something that you are personally interested in or is relevant to you. It might be based on something you read, some existing research that sparked an idea in you. Then the next step is to develop your hypothesis, a statement you can use that will allow you to test a prediction. So to develop your hypothesis, a good place to start is existing theories. A theory is based on a synthesis or a combination of past observations that have been used to explain something. At this level, in addition to developing your hypothesis, you're going to establish what's known as operational definitions. That means you are going to spell out very clearly what it is you're interested in, what you're looking for. Because we're going to see, to be a good science, we're going to have to ensure that it can be replicated. So unless you have clearly defined what it is you're interested in, what exactly you're trying to measure, someone else might not be able to look for or measure the same thing. So at this level, you are also identifying what are the variables you're going to study. And we're going to learn more about the different types of variables shortly when we talk about experimental research. Once you have your hypothesis, then you have to come up with a way that you are going to study it and collect your data. And we're going to see that there can be different levels of research. Last chapter, when we were introducing what psychology is and talking about how broad of a field it is, we said no matter what area of psychology you're studying, there's always 4 goals in common. Someone is either trying to describe, explain, predict, or control something. And we're going to see that there are research methods that apply to each of those goals. Some studies are only trying to describe something that's going on. Some studies are actually trying to figure out what is the cause. They're trying to explain it. So in designing your study, you're going to come up with what you're going to do and how you're going to collect that data. And then once you have collected it, then you have to put that data in an organized way so that you can analyze it and determine if your hypothesis was supported or not. And then the 5th step is to share your findings. In the real study of psychology, this often means getting published. A good publication would be one that is peer-reviewed. That would mean that before your work is published, other psychologists, other people in your profession would review it. And this gives you some confidence that your results can be trusted. If other professionals have reviewed it and judged it to be worthwhile, then it gives you an extra layer of credence. Because ultimately, if you find something important, we want other people to have this knowledge so that they can use it in generating their own ideas. And more importantly, as we're going to emphasize later in this chapter, to be able to replicate your results. We're going to emphasize being able to replicate results. The more research that can be done on the same topic and end up with the same kind of results, the greater faith we have in whatever those results are. All right, so now we're going to talk about some terms you need to be able to understand in research, and the first is variable. Variable simply means something that you're going to measure in your research. Something that can, like the name suggests, vary. It could vary over time. It could vary between groups of people. So that is the definition of a variable. The next learning objective is to be able to distinguish different types of sample, a random sample and a representative sample. So first, let's talk about what a sample is. A sample is a subset of the entire population. The population are members of a group that your research is going to apply to. So for sake of example, let's say I had some idea of a good study strategy to help introductory psychology students in college. And obviously, if this study strategy works, then I would want every person who's taking an introductory psychology course to be able to benefit from it. So my population would be every single college student taking an introductory psychology course. Now, obviously, I can't gather data on all of those students if we consider every single college in the United States. So we take a sample. We take some members of that population to gather our data from. And if we design a good study, even though we've only studied a subset of the population, we should be able to make some inferences that if it worked for this group, then it should work for the population from which they are drawn. Now again, that only is going to be able to be possible if we have a good sample. So the ideal is what's called a random sample. That means everybody in the bigger population has an equal chance of being chosen to participate in the study. So if we wanted to conduct that study on introductory psychology students in a college course, then that would mean I would need to get the name of every single student enrolled in an introductory psychology course in the United States, and then randomly pick out a manageable number of those people from whom I'm going to collect data. And if everybody has an equal chance of participating in the study, then any differences between the people would sort of balance each other out. Now let's say instead you're a lazy researcher and you're not trying to get a random sample. Let's say you say to yourself, well, I've got 30 some students in my class. They're a captive audience. I'll just gather my data from them. Well, there could be something about you that's already different that might make you more successful in an introductory psychology course anyway. That has nothing to do with the study strategy I'm trying to test. So obviously your MCC students taking it with me, we already know you're smarter than the average student, right? So there could be something different about you. Whereas if we have a random sample, I could just as easily have a really smart student with good study habits as somebody who's not such a great student with good study habits, and everything in the end should balance out. That's what's known as a random sample. Now, random samples can be hard to come by. So we at least want to make sure that we have what's known as representative samples. That means whatever sample I get to participate in my study, they need to at least represent the bigger population on important characteristics. So, a real simple, silly example, let's just say you're studying the exercise behavior of men in their 50s, then that would mean everybody who participates in that study should be a man and should be in their 50s. You'll have nobody 40, you'll have nobody 60, you'll have no women. To go back to our studying the study strategy example with intro psych students, then that would mean we would want to get the demographics of the whole population and be sure that even if my sample is not random, that I at least have the right proportions of men versus women, of 18-year-olds versus 20-year-olds, of different demographics, of socioeconomic status, of different races, whatever is pertinent, we want to be sure that the sample represents that larger population that we want to apply our results to. So the next objective is to talk about descriptive research, that very first goal of psychology, describing some phenomenon. So this is often a good starting point for research. It's often where new ideas start. When there's not a whole lot of research done on a particular topic for you to read about on your own, then you have to gather that data fresh for yourself, often by first doing descriptive research. Like the name suggests, you are simply describing the phenomenon of interest. You are not able to make predictions. You're not able to talk about cause and effect. All you can do is describe the kind of information you've gathered. We're going to see this can be incredibly detailed and informative research. It can be described in quite a bit of detail, but just because you have observed and described something does not necessarily mean you know why it happened or that it would ever happen again with another group of people, for example. So one type of descriptive research is known as a naturalistic observation. This means you go right into the environment where something is happening and you observe it in the natural setting without interrupting what's going on, being as unobtrusive as possible. So let's say, for example, you wanted to conduct a naturalistic observation of the note-taking behaviors of college students in a college classroom. To do a naturalistic observation, that would mean you go into a college classroom and you watch for yourself how college students take notes. But to do a naturalistic observation, that means you're doing it in a way that you're not letting them know that they're being watched, that you're not interfering with what's going on. So with that example of a topic, you might pose as a college student yourself, sit in a college classroom, but unbeknownst to everyone around you, you aren't taking notes on what the lecturer is saying. You are taking notes on how everyone else is taking notes. Another type of descriptive research is a case study. A case study is where you collect lots of detailed data on an individual or a small group of people who have some kind of unique condition or some uncommon thing that happened to them. So you have some examples of case studies here. So probably within, forget when, probably within the last decade, there were a group of miners in Chile who were trapped underground for like over a month in very close quarters, very limited contact to the outside world. They all were rescued, um, but it took a long time because there were concerns that if they dug in to save the men, the mine would collapse, killing them all. So it was a long, like month-long process where this group of men were stuck underground, mostly in the dark, close quarters. So when they were rescued, researchers gathered lots and lots of data on their experiences, because that was a rare, unusual situation that happened. So they gathered lots and lots of data about what was it like to be stuck in the dark, away from your family, with these men in tight quarters and everything like that. Obviously, there's other ways you could research that, but if you were to ask for volunteers to go through that experience so you could figure out what it was like, who's going to volunteer for that? But because it happened, the data was gathered on it, and that's what's known as a case study. Here's another famous case study. We're going to cover this one next chapter in the biology chapter. This is Phineas Gage. Phineas Gage was a railroad worker who he was a foreman and working at the time when the railroads were expanding across the United States. And there was a blasting accident where this metal rod was blown clear through Phineas Gage's skull. Came in under, blasted out through the frontal lobe, landed yards behind him. He got to his feet and walked away. He's walking, talking, not in any pain. But he had a huge chunk of his brain blown out in the frontal lobe. And that's a rare, unusual phenomenon. So because that happened, lots and lots of data was gathered about Phineas Gage. And we're going to see in the chapter on the brain, a lot of our earliest understandings of the brain came from case studies, came from people who had some unique damage to a particular area of their brain. And after they had that damage, they might have lost a particular skill, changed in their functioning. So it started leading us to what do the different areas of the brain possibly do, so that we could then investigate them with other research methods. You have this table in your textbook. It just gives you some of the famous case studies, many of which we're going to talk about this semester. So last chapter, when we were talking about the different perspectives of psychology, and we talked about the behavioral perspective, you were introduced to the case study of poor little Albert. In the biology chapter, we're going to learn more about Phineas Gage and what it taught us about the frontal lobe of the brain. In our memory chapter, we're going to see the case study of HM, someone who had some brain damage that resulted in some memory loss. So it started to teach us what areas of the brain are responsible for memory. Another type of descriptive research is a survey. A survey is simply having a standard set of questions that you are going to pose to a group of people, and they're all going to be asked the same type of questions. Those questions could be asked in person in an interview. They could be a paper and pencil test. In modern day, we have a lot of internet survey research. And this has really improved the quality of survey research, because if with the internet you can reach lots of different people very easily, send out a survey to various identified demographics, and if you can guarantee that they're going to be anonymous, many people will answer survey questions over the internet that maybe if you asked them face to face in person, maybe about sensitive topics like, drug use, sexual behaviors, things like that, they might not answer honestly, but because they are answering over the internet and they're not identified, they might give you more honest answers. So that is survey research. The next level of research is correlational research. So we talked about those 4 goals of psychology: describe, predict, explain, control. Correlational research can help us do some prediction. If we know things are correlated and we know what's going on with one variable, we can make a prediction about what is happening with the other variable. So correlational research is a descriptive research method that tells us about a relationship between 2 variables. So if there's what's known as a positive correlation, then that means that the 2 variables are changing together in the same direction. As one goes up, the other one can be predicted to go up. As one's going down, the other one can be predicted to be going down. So this is a scatter plot of energy level in compliance with a yoga routine. And you're going to see the more somebody reports compliance with a yoga routine, the more energy level they're reporting. The less energy level somebody's reporting, that we can predict the less they've complied with the yoga routine. And if you look at that scatter plot, you can see all the points are sort of going in this direction, that as one increases, the other increases. A negative correlation means that as one variable is increasing, we can predict that the other one is going to decrease. So this shows compliance with meditation and cigarette smoking has a negative correlation. So the more you have of compliance, we can predict the fewer cigarettes you smoke. The more cigarettes you smoke, we can predict that you're going to have lower compliance with meditation. There's a negative correlation with vaccination and illness. So the more vaccinations you have, the fewer instances of illness you have. That is a negative correlation. And when we see the points on our scatter plot all over the place and we don't see a pattern, then that gives us the impression that there is no relationship, there is no correlation between the 2 variables. We can't predict one from the other. So when we do correlational research, the statistic we're going to obtain is known as the correlation coefficient. Again, you need to know what it means at this point. You don't need to know how to calculate it yet or anything like that. If you are majoring in psychology, you are going to have to take a statistics course, and we have excellent professors here at MCC who teach our stats courses. For intro psych, you just sort of need to conceptually understand it. So a correlation coefficient is a statistical measure that can only range from a positive 1 to a negative 1. The closer you are to either a positive 1 or a negative 1, the stronger the relationship is between the 2 variables. So a perfect positive 1 correlation would mean every single point would be right on that line. That as one variable increased, the other one increased the exact same amount, that they're changing in the same direction. One thing you should know about correlational research, especially in psychology as it applies to human beings, we're not perfect. We never find perfect correlations, but the closer you get to a positive one means the stronger the relationship is. A perfect negative correlation would mean, again, every dot in the scatter plot would have to be right on that line. That would mean as one variable increased, the other one decreased by the exact same amount. They go in opposite directions. Again, we never find perfect positive one or negative one correlations, but the closer you are to a negative one, again, the stronger the relationship. So if you know that one variable is going up, you can predict the other one's going to be going down. Now, one thing that you have to keep in mind is that just because you know two variables are related, and you might be able to predict what's going to happen with one if you know the other, as common sense as you think it might be, you can't assume that you know the cause if all you have is a correlation. So correlation does not equal causation. It just means I know there's a link there, I know there's a connection, I know these two concepts are related. And sometimes people in the media, people outside of science, misinterpret correlation, and that can result in some of those myths and fallacies that we talked about last chapter getting out there in the popular belief. So for example, there was a famous correlational study that found a strong positive correlation between kids watching violent TV programs and actual acts of aggression. And it was misinterpreted by some when it was reported in the media that watching violent TV causes kids to behave aggressively. Well, if all we have is correlation, we can't jump to that conclusion. That could be it. It could be that watching violent TV makes you aggressive, but it could also be you're aggressive and therefore that makes you want to watch violent TV. You're already aggressive, so you're drawn to acts of aggression. Or it could be what's known as the third variable problem. There could be something else that you did not even think of to measure that is causing the change in both of those other variables. And in fact, with regards to that third variable problem, with regards to that study on violent TV and acts of aggression, it's pretty much what they found, that there's another variable, adult supervision, that could influence both of those variables. So if you have no adult around, say the kid's coming home from school and there's no one around to supervise until mom or dad get off work. So there's no one to tell the kid, we don't watch, inappropriate TV shows like that show violence. Likewise, if there's no adult around to check their behavior, no one to say, hey, we don't hit our little brother like that, the kid could develop aggressive habits. So this third variable could be causing both of them. So it's important that we interpret correlation correctly, that we understand two things are related, but we can't determine the cause. Well, you might ask yourself, well, why not? Wouldn't we want to be able to explain things? Oftentimes we do, but there are times when it's simply not feasible to really determine the cause. You might have to do things that really aren't ethical. So for example, we know that there's a strong correlation between playing first-person shooter games and actual acts of violence. We know there's a strong positive correlation between those two variables. Does that mean playing violent video games makes you become a school shooter, for example? Well, we don't know. We can't say that. And to really figure that out, we would have to do something like randomly get a group of people, split them into two groups randomly, make sure that each of them plays a particular type of video game. Let's say for the next 6 months, group A is going to play a first-person shooter game. Next, the other group is going to play a non-violent game. After those 6 months, we're going to pass out automatic weapons to everyone, and then we're going to keep track of, in the next year, how many people do they all kill. If the people who played the violent video games actually end up shooting people and the others don't, well then we can say, yes, playing violent video games makes you violent. Obviously that's a ridiculous kind of study. So there's times where we have to be content with saying, I know there's a connection here, but given what we know, we can't go further. Now, the one research method that can address that explanation cause, that explanation goal of psychology and determine cause and effect is experimental research. In experimental research, the researcher, the experimenter, manipulates one variable to determine if it has a cause and effect on another variable. So if everything is the same between two groups, except for the one thing that the experimenter wanted to investigate, and we then found a difference, then we could say, okay, we can determine the cause. So the two types of variables are the independent variable and the dependent variable. The independent variable, again, is the one the researcher manipulates, the one that is under the researcher's control. Often, this is in the form of what group a participant in a study is assigned to. So there will be an experimental group and a control group. So let's go back to our simple idea of testing a particular study method. So if I've selected participants for a study, I would put them into two different groups. One group is going to be my experimental group that tries the new study method. The other one is going to be my control group, the one that I'm just going to use for comparison. They're going to do what they normally do. And then I'm going to use random assignment. That means when I put my participants in those two groups, that everybody who's been chosen to participate in my study has an equal chance of being either in the experimental or the control group. Now, some studies are known as double-blind studies. That means that there's somebody without a vested interest in the outcome of the study, like somebody involved in the research who knows what group people are in. But the experimenter himself, who is conducting the research, does not know who is in what group. That allows us to minimize experimenter bias. Let's say, for example, that instead of a study method, I have developed a new medication that I think would be good for treating a particular condition. I have a vested interest in proving that medication works, because that could make me a lot of money. If I didn't do a double-blind study, that might lead me to, maybe look for changes, look for benefits in the experimental group in comparison to the control group. If it's double blind and I don't know who's getting the real pill and who's getting the fake placebo pill, then I can't be biased. That's known as random assignment. And then the dependent variable is the outcome that the researcher is trying to measure in the end. So if we go back to our example of testing a particular study strategy in an intro psych class, maybe the dependent variable is a pre-test and post-test score. And if I find that the only thing different between the two groups in my study were whether or not they used that study method, and I find that the test scores of those in the experimental group who used the study method were better, they got higher test scores than those in the control group, then I can say, because the study method was the only thing different, then that is accounting for the change. That is determining the cause. So the dependent variable is the outcome you're measuring in the end. Now, we're going to see when we talk about statistics shortly that even in a well-designed experiment that can talk about cause and effect, researchers will still be very careful about reporting their results. And they will say things like, the hypothesis was supported, or we failed to support the hypothesis. You're not going to hear people say we proved something, or they're going to report, probabilities. I'm 95% confident that the results we got are because of the treatment and not because of chance. That's because there always is chance. As slim as it may be, there's always what's known as the possibility for an extraneous variable. Something outside of the study, something that you're not researching, that could have influenced the outcome. So that is what is known as an extraneous variable. There are various types of extraneous variables. A confounding variable is a particular type of extraneous variable. It's a variable that changes in sync with the independent variable that makes it really hard to figure out what really had the impact on the dependent variable. Was it my independent variable, what I manipulated, or was it this confounding extraneous variable? So let's say, for example, I have this hypothesis. It is hypothesized that caffeine supplements will have an effect on participants' sleepiness. So if I'm seeing changes in my participants' levels of sleepiness, and the only thing different about them is whether they took the caffeine supplement or not, then I could say, well, it was, with some degree of certainty, the caffeine that brought about that change. But a confounding variable might be, well, what time of day did I take my data? Because if I took it early in the day or late in the day, that also could have an impact on somebody's sleepiness that has nothing to do with whether or not they took the caffeine supplement. That would be an example of a confounding variable. Now, another variation of the experimental design is what's known as the quasi-experimental design. So we said in true experiments, a gold standard, once we have random selection from the population of people to participate in a study, then we have random assignment into the experimental and control groups. Well, in quasi-experimental designs, that means random assignment is not possible or ethical. That means we can't randomly assign you to one condition or another because of some pre-existing characteristic. So let's say, for example, I am interested in studying something about people who have major depressive disorder. It's a pre-existing condition. So that means I'm not randomly assigning you to be depressed. I am selecting you because you already have that pre-existing condition. And I might be comparing people with that diagnosis to those without it. And if I find a difference, then I'm going to make the inference that, let's say I'm testing a particular treatment on, major depressive disorder. Again, I can't assign you to that condition. It is something that is already existing, and you're going to compare people with that diagnosis versus people without. All right, so now we're going to talk about concepts of reliability and validity. Again, not something you need to be able to calculate for yourself right now, but to understand what those concepts mean. We're going to start with reliability. Reliability means how consistent or stable are your results. There's a couple of subtypes of reliability. So test, retest reliability would mean, let's say I measure you on a particular variable and I use a particular instrument, a particular test, and then maybe 6 months later, I measure you on that same variable using the same test. Do I get the same kind of results? That would be an example of test, retest reliability. Another subtype is known as inter-rater reliability. So this applies to when you have different researchers measuring the same kind of variable. So if two different psychologists were to gather this data of the same people, would they get the same results? Would each of those raters end up with consistent results? That's what's known as inter-rater reliability. Then there is the concept of validity. Validity refers to how accurate your data collection was. Did you really measure what you intended to measure? There are two types of validity: internal validity and external validity. So internal validity means I had a well-designed study. I did all I could to control any of those extraneous variables from interfering, and I spelled out my procedures and carried them out consistently with everybody. I did my experiment very well, and I measured exactly what I intended to measure. That's internal validity, not doing a sloppy experiment. External validity means once I have my results, how well can I generalize those results to other groups of people, to people who didn't necessarily participate in the study? Can I generalize the findings to the population at large? All right, our next example is to understand and be able to talk about descriptive statistics. So descriptive statistics is a way that you can organize and sum up your data that you're getting from descriptive research. So let's say we did a very simple survey study. We went on a college campus and we surveyed among college students, how many hours do you exercise each week? So the first thing we want to do is have our data organized. One way we can do that is in what's known as a frequency distribution table. So you take all of the answers you were given and you put them in order. So these are the answers you were given. These are the number of people you surveyed that gave you that answer. Typically, if you look at published research, you will also always see the data represented graphically in some type of either a histogram or bar chart like this, so that at a glance you can visually see, most people are saying they exercised 2 hours per week. Or we could do a simple line graph, a frequency polygon. Again, a way of visually representing the data that you get. Now, not only do we want to have organized data and data presented in a nice visual format, but we also need what's known as measures of central tendency. This is a single number that can represent your whole data set in a very compact, neat form. So let's say, for example, I did this descriptive research on exercise behavior of college students, and then one of you posed the question to me, said, hey, Dr. C, how did that research on exercise behavior go? And I say, well, I'm glad you asked. Let me tell you. Well, I had 4 people who said they didn't exercise at all. I had 7 people that I asked, and they said they exercised 1 hour per week. I had 8 people who said they exercise 2 hours a week. I had 4 people who said they exercise 3 hours a week. Already, your eyes are glazing over. You're thinking to yourself, well, that's not what I wanted. Why the heck did I ask him that question? Is he ever going to shut up? I just want the gist of it. Sum it up for me. That's what a measure of central tendency does. So we're going to learn about 3 measures of central tendency. So we're going to use this data set here. So let's say we asked 20 people, how many hours a week do you exercise? So the simplest measure of central tendency is the mode. The mode is simply which answer was given the most. In this case, then that would be 2. The median is what number is right in the middle. So we have 20 participants here. So we look for where our middle is, and it would be right there. 2 plus 2 equals 4, divided by 2 is 2. So 2 is our median. Let's say instead that we had, instead of a 2, we had a 1 and a 2. And right in the middle would be somewhere in between. In that case, our median would be 1.5. But the number that would be right in the middle here is the median. If you have an odd number data set, then that's going to be nice and easy because there is going to be a number that's right smack dab in the middle. But if you have a even number, then you have to do a little bit of calculation to figure out which one is in the middle. And then finally we have the mean. You already know the mean. It's the average. You add up all your numbers, divide by the total. So with this data set, I can say I have a mode of 2, a median of 2, and a mean of 1.5. Well, why do I need 3 types of measures of central tendency? Well, the reason we have 3 measures of central tendency is because if we relied on only one, if we relied on just the mean, if we have some extreme numbers, the mean is always going to be pulled in the direction of that extreme. So let's say, for example, instead of exercise behavior, I conducted a study about family income. And I gathered all my data, and I have this one millionaire in my sample. And he grosses 1.4 million a year. Then that means when I calculate that mean, he's pulled in that direction. So if I were to come back to you and say, okay, I did this survey on the mean family income of, college students or whatever, and I said, and the mean is $140,000, you might think, who are you talking about? Have you seen the lines in the financial aid office? That doesn't sound much like anybody I know. But then I said, but wait, but the mode was 40,000 and the median was 60,000. You might start saying, okay, that sounds more like people I might know. That's more realistic. So when you have, this different mean, then you're automatically getting cued into, I've got some extreme scores here. So having 3 measures of central tendency is a way for us to, really analyze that data set and carefully come to the right conclusion. So another aspect of descriptive statistics is, well, what kind of variability do we have? Do we have any of those extreme scores? Well, the simplest measure of variability is simply the range. This is the high score, this is the low score. The range is in between. A more standardized way of talking about variability is to calculate the SD, or the standard deviation. Again, not something you need to know how to do right now, but something conceptually you need to know about and what it means. So for example, we gathered information on weights of these individuals. We calculated the mean and we found we have a mean of 124 pounds. But if you look at your people, not a single one of them is exactly 124 pounds. So to calculate the standard deviation, we take each value that we gathered and we subtract 124 from it so that we can see how far away from the mean are you. Now, when we have lower values that were lower than 124, we're going to end up with negative numbers. Now, I'm going to be quite honest with you. My math skills have not progressed much beyond middle school. However, I do know dealing with negative numbers mucks things up, And even I know with my limited math skills that if you multiply a negative by a negative, for some reason you get a positive. So to get rid of all of our negative numbers, we square each one of those values. So we end up with now all positive numbers. So we multiply each one of these numbers by itself to get a positive value. We sum all those up. We divide by the total. Because we squared all of these values, we then take the square root of it to undo it, and we end up with a standard deviation. So the higher your standard deviation, the higher the variability, the more spread out those scores are. Again, why is that important to know? Well, because if you're conceptually trying to understand a set of data, you need to know that. Because if you imagine under these curves represent how many people get a particular score. Both of these data sets have the same mean. But if you look at the green curve, you're going to see you've got a lot more people who are close to the mean and not many that are spread out. Whereas the red curve, it's a flatter curve. You got more people in your extremes. Knowing your standard deviation would let you know, do I have a very compact curve or do I have a very variable spread out curve? Now, a lot of human characteristics that we're going to study, things like IQ, for example, distribute in what's known as the normal curve or the bell-shaped curve. This is a distribution that is symmetrical. You have the exact same number on one side of the curve as you do the other. You have the most people near toward the means, and the farther away you get from the extremes, the fewer and fewer people you have. So again, this is how IQ scores distribute. Most people are average. The farther you get over to either the high IQs where you have the geniuses, the fewer people you have. The lower you get where you have people who are far below average and impaired, the fewer you have. Most people are near the center. That's known as the normal or bell-shaped curve. Now we're going to talk about a different type of statistic known as inferential statistics. So this is the kind of statistic we use to sum up our experiments, to sum up those studies where we're actually testing hypothesis. So inferential statistics tell us, did these results that we get happen by chance, or did they happen because of what we hypothesized was going to happen? Did they happen because of our manipulation of the independent variable and not simply by chance? Inferential statistics are a mathematical method that allows us to make inferences from our sample back to the population from which they are drawn. So it's telling us what is the likelihood that the same thing would happen again if we were to conduct it with a different group that was drawn from this same population. So tells us what's the chances that if we did the exact same procedures, measuring the exact same variables, we'd likely get the same thing, versus could it have happened by chance? Now, we discussed before the importance of replication. The more a study can be repeated with the same results, the more confidence we have in whatever those results are telling us. So meta-analysis is a way of statistically analyzing a group of studies that are testing the same topic. It's a way of combining the results of multiple studies to come to some general conclusion. All right, the final objective in this chapter on research is how can we do all of this ethically? There are some foundations of ethical research. One is informed consent. In most circumstances, we want participants to know what the study is about, what they are getting involved in. Typically, they're going to sign a waiver that tells them as much as we can. Typically, it's going to tell them whether they're getting any benefit from participating, whether they're getting paid. It tells them about any risk or discomfort that they might expect. And typically the informed consent is also going to say things like, if you change your mind, you can drop out without any prejudice toward you. Now we're going to see informed consent, again, it's the gold standard, but it's not always possible when we're studying human behavior. In social psychology, later in the semester, we're going to see a lot of interesting studies where they're studying human behavior and they clearly could not tell people what the study was about. Otherwise, people wouldn't have acted naturally and given genuine results. So for example, there were studies done on testing the conditions under which someone will help somebody in need. So they would stage these fake accidents. You know, somebody seems to have a seizure or a heart attack in front of you and they wanted to see whether someone's going to help or not. Well, if we told you in advance that we're going to bring you into this study and while you're there somebody's going to fake a heart attack, well, if you already knew it was fake, you're not going to behave real. So we can't always tell the person everything. Another component of ethical research is confidentiality, especially when we consider good research is ultimately going to be published. We don't want to put everybody's business out there. So we guarantee that if you participate in a study, we're not going to put your personal information out, even if it's just about you and it's a case study. We're going to just refer to you by initial or something so that people don't know who you are. This is why it took so long to really figure out who poor little Albert is. And then another component of ethical research, particularly when we can't have this informed consent, is debriefing. That means after the study is all over, we tell you anything that we could not have told you up front. If we had to deceive you, we tell you why we couldn't, tell you the truth. We tell you that, well, we know, we fooled you. We made you think somebody's having a heart attack. Well, that's because we wanted to study helping behavior. And if you knew it wasn't a genuine emergency, you might not have, behaved naturally. We make sure everybody's feeling good and understands everything about the study when it's all done. Other ways to ensure ethical research is to simply follow the recommendations of our professional organizations. We have professional organizations like the APA, the American Psychological Association, that was founded by William James, that you learned about in Chapter 1, that for, the entire American history of psychology has put forth guidelines and monitored the ethics of people to ensure that what psychologists do we're doing for the best interests of everybody involved, that we're not harming our participants, we're doing our best to preserve the welfare and integrity of both animals and humans used in research, that we are not faking our results, that we're presenting things truthfully, that even if our results don't turn out the way we expected and we were wrong, we still say it didn't turn out as we expected and we're wrong. Another way to ensure ethical research often is what's known as institutional review boards. A lot of research in modern day is sponsored by, funded by organizations, universities, colleges, drug companies, whatever. So those kind of organizations would have these committees where before they give their stamp of approval to have that institution's name associated with your research, that committee would have to review what you intend to do. You would have to present your intended research to this institutional review board. On this committee would be people who are psychologists as well as people outside of the profession. So even to a lay person, you would have to present your stuff in a way that would make them see the value of authorizing that research and giving their approval before a university or organization's name is associated with it. So that wraps up Chapter 2 on research methods. Thank you for watching. I hope this was helpful.